In this video, we will be learning machine learning in Python, and this video is going to be very useful for the beginners who want to get their hands dirty on machine learning. So, the approach of this video is going to be unique. I am going to explain all the basic concepts of machine learning while doing a project in which we will try to predict the closing prices of a popular cryptocurrency, Bitcoin. So, our output will look something like this, and I will explain everything. So without wasting further time, let's get started. So for the beginners out here, first of all, what is machine learning? Machine learning is when our machine, that is our computer or mobile or any smart electronic device, learns to do a complex task and it is trained by a human. So there are three types of machine learnings. One is supervised learning, second is unsupervised learning, and third is reinforcement learning. The type that we require to predict the closing prices is the supervised learning. So let me explain these three types of machine learning in short. So what happens in supervised machine learning is, let's suppose here is a small child and he wants to walk on a given road. So this road has potholes at random places. So in supervised machine learning, there will be an adult with this child. So this is our adult, and he knows that he should avoid these potholes. So this adult will hold the finger of the child, and he will guide him to walk on this road. So he will not. So the adult will actually supervise the child and tell him that you don't want to step on the pothole, and instead you should avoid them. So this is what is the concept of the machine learning, of supervised machine learning. So in supervised machine learning, we will give the machine what the machine wants to predict. So we will tell the machine that okay, suppose this is the machine. So we will tell it that you want to predict this. Let's say it's X, and we will give him the data Y. So it knows that when it receives the data Y, it wants to predict X. So this is what is known as supervised machine learning. Now this is the part of the training process. So actually when the machine actually when the model will predict, it doesn't require this X. So we will only give it Y. Okay, now let's understand unsupervised machine learning. So as you can guess from the name, okay, let us take our child first. So this is our child. Now again he wants to walk on this road. Here are the potholes. But this time he won't be accompanied by any adult. So what he wants to do this time is he will go and explore the way all by himself, like a brave man. Okay, so he might go here, and then he might know that okay, this is the correct way. So now he might go here, but once he goes here, he will discover the pothole. So the child might fall in this pothole. So once he falls in the pothole, he knows that okay, potholes are dangerous for him, and he won't go here. Like he won't go in this pothole again. So now he will take this way, and from here he will go like this. Again he will discover this pothole, but this time he won't fall in the pothole. Instead, he will now change the way before he falls in the pothole and go here and go here. So likewise, he will navigate the road all by himself while exploring the road and where are the potholes. So this is what is known as supervised machine learning. So in this process, let's say again here is our machine, and just like before, we will give this machine will try to predict let's say X, but now this time while it is training, we won't give it the what he wants to predict. So there will be no Y in this case. So try to explore what it wants to predict, and as he explores, the machine will know by itself that okay, what it wants to predict is X, and now he will learn how to predict this X. So this is what is known as supervised machine learning. Okay, so now let us talk about reinforcement learning. So the concept of reinforcement learning is slightly different than supervised learning and unsupervised learning. Now let us say that this is the house of the child. The child is currently standing here. Okay, so now the child wants to find out where his mother has stored chocolate. So let us say that this is the kitchen in his house and here is a chocolate. Okay, so let us imagine that this is the hall of his house. This is the bedroom. This might be another bedroom. So the child basically doesn't know how to go to the kitchen. So he doesn't know what is the exact path to go to the kitchen. So what we will do to train the child how to go to the kitchen, we will keep maybe some bits of chocolate here, like in the bedroom, in the hall, and again in another bedroom. So now the child will first explore and go to the first bedroom. Here he will find out a bit of a chocolate. So this is not the actual whole chocolate, but just a piece of the chocolate, bit of chocolate, whatever. So now the child gets motivated. He knows that the chocolate just is delicious. So now he gets motivated to move further and find the actual whole chocolate. So now the child might go here. He says, okay, this is the bedroom number 2. So he might go here and he might eat the second piece of chocolate kept here. So he will get more motivation. So it's like a reward system for the child. So now the child will say, okay, now whatever happens, I have to find out this chocolate. But what the child does, he again comes back to the first bedroom. Now when he comes back to the first bedroom, he has already eaten the chocolate. So there is no chocolate here. So he doesn't get anything. So he doesn't get any reward. So what happens? He knows that this is a wrong way. There is no reward. So he isn't getting any reward. So what he will do, he will again find another way. And likewise, he will reach the kitchen and get the final reward, that is the whole chocolate. So this house, this whole house is called as environment. This child is called as agent, and the small and the smaller pieces or the bits of the chocolate that he was getting when he was at the right path, that that is called as the reward. And the time when he came back to the path and like he came back to the first bedroom and he didn't get any piece of the chocolate, so that is basically penalty. So he didn't get any reward, instead he got demotivated. So that is known as penalty. So in reinforcement learning, what the concept is, there is an agent. Whenever the agent tries, whenever the agent goes in a right way. So let's say this is our machine. In our machine there is an agent, let's say A. So whenever he predicts and he wants to let's say he wants to predict X. So whenever he predicts X, or he predicts something close to X, so like Y or maybe Z or something like that, we will give him higher reward. So that might be plus Y, plus 6 or something like that. And whenever he predicts X, which is what he wants to actually predict, we'll give him a lot higher reward. So that might be plus 10 or something like that. This agent will always aim to get higher and more and higher rewards. And whenever he predicts something awfully bad, like let's say he predicts B, which is far away from X, so he might get minus 5. Let's say he predicts C, which is again far off from X, so he might get minus 2 or something like that. So this is what is known as penalty, and these are what is known as rewards, and this is our agent, and this whole thing takes place in an environment. So this is basically the reinforcement learning. And at this point of time, sorry for my bad drawing, but yeah, understanding the concepts is the main thing. So now once you know all the three types of machine learning, you must understand that machine learning is basically a subset of artificial intelligence. So whenever someone says that AI is involved, you must know that under the hood machine learning is also involved in the process. Now let us talk about another core concept of machine learning. While training the machine, there is something called as model. So to understand this conceptually, let us imagine that this model is basically a magical jar, and we can put anything inside this jar. It can be like a square, a rectangle, or a triangle, or even a circle, anything. And or it can also have like, just a number of squares or just a number of rectangles. So this is our magical jar. Okay, let me erase that first. So this is our magical jar. It can have mixed things as well as uniform things. That doesn't really matter. So what we will do, we will give something as an input to this jar. This jar will process the input according to the contents of the according to its contents and give us some output. So during this process, the jar basically tries to improve its output. So to do this, the jar might arrange the contents like, since we have given it, let's say in this case the jar has one square, one rectangle, one triangle, one circle. So the jar might arrange the position of this content. So first, like in the first case, there is first there is a square, then a rectangle, then a triangle, then a circle. But now the jar thinks that okay, this output can be improved, so take he might arrange, in the second case he might arrange like this. So first there might be a rectangle, then there might be a square, then there might be a circle, and then there might be a triangle. So now again he will take a bunch of inputs and process them, and then again give some output. So likewise, the jar takes an input, gives the output, and also at the same time, the jar arranges the contents according to the output. So this is what is called as model. Okay. So for now, this much info about the model is more than enough to know at this point of the video. So now you will come to know in more detail about the model once we start writing the code and once we go ahead with our concepts in machine learning. Concepts about machine learning. So now let's go further. So let us understand the basic process of machine learning. So what happens basically is like the basic steps of the machine learning. So first we have the data. First we have the data that we want to predict. Let us represent it by letter Y, and we have the data on which we want to train the machine to predict this data Y. So this is known as training data and this is known as the prediction data. So let us denote the training data by D, and this is our model. So like before, this is our, let us imagine this to be a jar which has some contents like triangle, circle, square, rectangle. And now what will happen is this model will try to predict this data which is Y, and we will give, and this model needs to train itself to predict this data Y. So it will train on this data which is represented by D. So we will feed this data D to the model, and it will try to predict this data Y. However, it is important to note that it just tries to predict the data. So it is not so the output of the model might not be exactly the same. So let us represent this output of the model by letter W. So the data that the model predicts is represented by letter W. The data that the model wants to predict is denoted by Y, and the data on which the model trains itself to predict data Y is represented by data D. However, here is a big chunk of this process is missing, and that is known as data processing. The problem is, since you can see this jar has only square, rectangle, circle and triangle, so we can't directly feed this data to the model. This original data might be so large that the model doesn't understand anything. And also, like, if we don't process this data and feed it directly to the model just can't predict the data that we want, that we expect the model to predict. So what we will do is we will perform some mathematical calculations on this data. So like we will perform these mathematical calculations on each value of this original data, and then what we will get is another data set, and let us represent this data set by letter A. So now the very important thing about this whole data pre-processing part to note is, let us say that the features of this data or of this original data, which are mean, mode, median, average and all that statistical features, those features, and if we find out the features of and if we find out the same features of this data represented by A, they will be the same. So basically we have changed the data by doing mathematical calculations in a way that the data actually remains the same. So this data represented by A actually represents this data D. However, it is not the same data. It is not the same data. We can say that it is similar to data D, but everything, mean, mode, median and all the statistical features of this data A will be exactly same as the statistical features of this data D. So now once we have this, we can feed this data to the model. So these are the basic steps of the machine learning process, and this is like very basic and very dry steps of this process. Again, you will come to know about this in detail once we start writing the code. And I think now is the time, since you know the basic steps of what we want to do, like you have a fair idea about it, now is the time to dive into the code. Okay, so before actually diving into the code, let me just correct this diagram. This is the correct representation of our diagram. Since we can't feed the data directly, we have to process it and then we have to feed it to the model. Okay, so let's get going with the code. However, it is it is important to note that I am not directly using Windows to do the machine learning, as I want to leverage the capabilities of my GPU. So I am using WSL, which is Windows Subsystem for Linux. Here at the bottom left corner, you can see that I am using WSL Ubuntu, and there is actually a cool plugin known as WSL in Visual Studio Code, uh, which is very useful to do this stuff on Windows. So now let's get started. So the first step was, as you can see in this diagram, the first step is to collect the data. So for that, I have this file named as datafetcher.py. Here I have two functions, and this function here fetches the data and stores it in a CSV file called as here you go, Bitcoin minute data. And this function here reads that data and returns it. Reads the data from the CSV file and returns it. So we are using a module called as CCXT. It uses Binance API. So if you know, Binance is very popular crypto exchange platform, and it is used worldwide. So we will use Binance API and we will fetch the data. So here, like this function takes three parameters: symbol, time frame, and since. Symbol is symbol. The symbol is necessary because this will tell our code to get get the data about Bitcoin. And this is the time frame. So if you have the basic knowledge about stock, you know that we can view the stock charts on a certain time frame. So like 1 minute or maybe 1 day. So or maybe 1 hour. So this is that time frame. And since is like the data that we want, it should start from when. So that is since. So since is actually date and time. So here we will here we will get the scenes parameter. We will format it according to this time, according to this date time format, and we have defined here an empty list called as all data. So this is our main loop that fetches, that queries the Binance API through this package called as CCXT. And here the first line of loop is fetch OHLCV data. So what is OHLCV? It stands for fetch open, high, low, close, and volume. So if you have the basic knowledge about cryptocurrency or even stock trading, you will know that open, high, low, close, and volume are very important parameters on which the closing price will depend. So we want all these values, open, high, low, close, volume, for a given time, for a given timestamp. So we'll pass the symbol. In our case, it will be BTC, since we want this data about Bitcoin. Then we'll pass the time frame. Then we'll pass since, and we'll pass a limit. So at a time, it will fetch limit. We have to pass this limit so that at a time it will fetch 1,000 data points. So like let's say about so now the time is 16:10. So let's say it will fetch. So if we have defined the time frame to be 1 minute, so at 16:10 it will fetch the open, high, low, close values. Then again at 16:11 it will fetch the open, high, low, close values. Again at 16:12 it will fetch the open, high, low, close values of that minute, and so on and so forth until it has accumulated 1,000 values, and then it will return this value and store these values in data variable. So now, like this, if the data since it can't, so like now the time is 16:10, so it doesn't, so the data will stop at 16:10. Okay, so it became 16:11, so the data will stop at 16:11. And if we try to fetch the data of future, so like if we try to fetch the data of 16:12, it will return 0. So that's the point at which we want to stop. So we will break the loop when length of the data is 0, and if it is not, then we will store the data, like we will break this loop and all this code will not be continued. And but what if it is not? If it is not, then we are actually collecting the data of the past time frame and of the timestamp, and we will append it to this all data, to this list which is all data, and store the data that we have received in this data variable on in this all data. So we will append it. We will not overwrite this list each and every time. Okay, so I skipped this line purposely. I wanted to explain what this does before, so you have a better understanding of this line. So here, once we have fetched 1,000 data, let us say that we have instructed this function to fetch the data from let's say like 2,000 or 5,000 time stamps before. So what it will do, it will fetch the data of the first 1,000 timestamps. So like once it has fetched the data of the first 1,000 timestamps, it will store it in the data variable, and then here we will give this data to this list which is all data. But now we don't want to again store the data of the same 1,000 data points. So what we will do, we will fetch we will fetch the last data point, which is specified here by -1 of this data, and then once we fetch the last data point, we want the first row, since by default the first row will be the timestamp values. So like 16:12, then 16:11, then 16:11, then 16:12, then 16:13, and so on and so forth. So we want the first column which will store the time, and then we want to increment it by 1. So what happens is, it will first fetch 1,000 data points. Then let's say the 1,000 data point ends at 16:12. Then now it will get to the last data point that it has fetched. Then it will get to the first column of this data point, which is time value. and then timestamp, which is timestamp, and then it will increment it by 1. So it will fetch the, so now since variable stores 16 13 instead of 16 12. So now it will automatically, so next time this while loop runs, it will automatically fetch the rest of the data. So first it will fetch first 1000 data values, then it will fetch the second 1000 data values, so like 1 to 1000, then 1001 to 2000, then 2001 to 3000, and so on and so forth. So now once we have this all data, what we'll do, we will create a data frame. Now data frame is a data type provided by pandas, which is another package in another very famous package in Python. It is used for all machine learning stuff. So we will create a new data type pd.dataframe, and we will store this in variable df. So what we will do, we will assign this data type, we will assign this variable all data, which is the data that we have received here, and inside this data type we can actually define columns. So like I said before, the first column will be timestamp, it will store the time values. The second column will be open, high, low, close, and then volume. So we will define that, so we will tell this data frame class that the first, we want the first column to be data frame class or function, that we want the first column to be timestamp, then we want the second to be open, then the third to high, then low, close, volume, and so forth. And also we will give this data. So by default it will take this data, it will assign the first column name as timestamp, the second column name as open, it will name the third column as high, and fourth column as low, and so on and so forth. So again, now we have a like one extra step to do in this data frame, which is again, as I said before, it is a data type which is provided by pandas package. So in this data frame we will fetch the timestamp column, and then we will format it to date time, since we know that the time that is stored in this timestamp column will be will be actually time and date. So we'll format it as date time, and we will use the unit milliseconds. So it will be stored in the format of milliseconds, and also days, I mean date. And then finally we will write it to the CSV file, which is known as Bitcoin minute data. And we don't want the function to add to automatically add index, since we will use since we have a column which has like unique values and which is timestamp. So we will use this as the index. This is okay. So and then finally we will print that we have saved the data. So to gain better understanding, let me open the CSV file. As you can see, it is really a lot of data. So here, as you can see, the first column is timestamp, and by the way, this CSV file is generated by our Python code as due to this function, which is fetch. So this is our first column timestamp, this is second open, third high, fourth low, fifth close, and sixth volume. So as you can see here, this is the date and this is the time. So these are hours, minutes, and seconds. So we have formatted it as date time, and hence it is stored like first the date, then the time, and in proper format. And it has since we have told the program to name the columns like timestamp, open, high, low, close, and volume, it has automatically named these columns, as you can see here. The first is timestamp, the second is open, high, low, close, and volume. Okay, so now we have all our data values in a single file called as bitcoin minute data.csv. So in the second function, where we will fetch these data values from the file and return it in the data frame data type. So it is very simple, pd.read csv and parse dates. Again, while it reads the values, we have to tell it that the column timestamp contains date and time, so parse it accordingly. And like I told you before, we have set the index to false, so we will have to provide the index. And here we have to, and we have passed this parameter index column to be timestamp. See, as you can see here, each and every value of this column timestamp is different, because this date is different, and the time itself is also different. So what we'll do, instead of creating yet another column, we will use this timestamp. We will utilize this timestamp as index column. So that is what we have told here, that let the index column be timestamp, and then we will, once execution of this line of code is finished, we will print that we have read the data, and then we will return the data. Okay, so this is the file that helps, that I have designed, that helps us to get the data from the internet, so store it in the CSV file, and then again also read it. So now let's come to the main file. This is the file in which we have done all our machine learning stuff. Okay, so first, as usual, we have done some imports. Here is our data feature file, and for now I have commented out this code because there is no need to fetch the data each time we run this code, as it is, as the time we fetch it, it is saved in this CSV file. So this is the same, but let me explain it to you. This is the symbol. As you can see, we want BTC, that is Bitcoin, and USDT, that is in US dollars. So the values of the price, of the closing price, and all that stuff should be in US dollars. So this is the symbol for it, which is BTC slash USDT. So we have chosen the time frame to be 1 minute. So all the values that we will fetch will be of the time interval of 1 minute, and we want this data from, this is the date, this is the since parameter, and it is the date. We want this data to start from the 2023, from the 2023 and the first day of this year, which is 10, and so the date is 0101 and 2023. And now finally, once we define these three parameters, we will call the fetch function that I explained you before here from the data fetcher file. So now once we have the data stored, let's go ahead. So here I have defined a variable called mainframe. It will fetch the values. From the CSV file. We have already stored these values in the CSV file by running this code, and then now we will read these values from the CSV file. And again, this data fetcher dot get data frame I have defined here, and as I told you before, it returns a data frame. So this main frame will be of data type, which is data frame. So now what we want to do is, once we have this data frame, I want this data frame to be in the format of array. If we want to do the mathematical calculations, it is very important for us to convert it in the form of array. So that is what I have done here. I have taken all the values from the mainframe data, from the mainframe, and by writing this dot values, it is automatically converted into array and stored in dataset. Okay, so before getting further, it is important to know that we have finished with the first step, and that was of collecting the data. So now what we want to do is data pre-processing, that is perform some mathematical calculations on this data, so that as I told before, so that we will get another data frame, but it will have all the statistical features same as the actual data. So let's get back on the Visual Studio window. So here, so now what I want to do is, I have this data. Let's say this is the data. So what I want to do, this is the data that is stored in the CSV file. What I want to do is, I want 85% of this data. So let's say this is 85%. I want 85% of this data for the training process of our model. The rest 15% that remains, that is, I want for that, this data I want for prediction. So as I told before, first we have to train the model, then the model predicts the data, However, we will have to give it some input to predict the data to give the output. So this is what this 15% will what will be the input to the model. So again, let's go back. So what I've done here is I have found out what will be the 85% of this data. So it will start from 0th data point to the 85 to whatever data counts to 85%. So here math.sil, this method rounds off to round. This method is used to round off to the nearest integer value. So this will return as integer and not some decimal or float. This len data set. So first we will have to find out the length of the data. So here this is our data set. As I told you before, this is in the form of array. This is no longer a data frame but an array. So we can get the length of this array, and what we'll do is multiply it with 0.85. So now we have 85% of the. So now we have where is the 85% of this data. So like if this is the first data point, then this is the second data point, and so on and so forth till 100. So this is the 100th data point. Okay, let me write it here. So now with the help of this line, we know that 85% will lie somewhere here, which will be 85th data point. So this 85th data point is what is 85% of this data. So now we know, let us assume that we have data which has total 100 data points. So now we have 85% of this data, means final data length will store an integer which will be, in this case, will be 85. So once we have that, we will now initialize the class for data pre-processing. So this is standard scalar. I've seen that many YouTubers use min-max scalar, but it doesn't actually fit with the concept of what we are trying to predict. So now let's get again into the technical stuff. So what we are actually doing is we have this data. As you can see, these are like numerically very big values. So this is something like 16,520, 16,526, and so on and so forth. So these are very numerically very big values. So we need to scale them down, and for that we are using this class called as standard scalar. So before we scale them down, what we will have to do is we will have to initialize this class called as standard scalar. I have seen that many YouTubers use min-max scalar, as I told you before. What it does is, let's say that this is the graph of our data. So let's say that this is the graph of our data. Let's say that maybe this is the highest point of the closing price of BTC. So this is the highest point of year or something like that. But now this is okay. Wait a minute. This is our graph. Let's say this is the highest point, and this is like the lowest point of the closing price of BTC, and it is something like this. So this is the graph of closing prices of BTC, which is what we are trying to predict. So as you can see, this is the highest point and this is the lowest point. So what min-max scalar does is it finds out the highest and the lowest points from the given data, assigns it 1 and 0, and then scales all the values in between 1 and 0. So it might be 1 point, it might be 0.05 or something like that, or 0.25, or it can be anything between 1 and 0. But the problem is, once we are done with all this stuff like the training the model and all those things, when we will actually apply the model, we can't be certain that this will remain as the highest point and this will remain as the lowest point in this graph. In the future, the BTC closing prices might fall below this closing price, and or they might go above this closing price. So now it will have new high and new close. So our model knew that during its training process, our model knew that okay, this is the highest point and this is the closest point. However, now while it is predicting the prices in the future, it it found out that this is the highest point. This is the highest point, which is actually higher than the point that it was given, that it came to know during its training process, or this is the closing point, which is actually, or this is the lowest point, which is actually lower than the lowest point that it knew during the training process. So this will really mess up the prediction process of the model, and then model might start spitting out like literally any values. So this messes up all the process of our training and predicting, and hence we can't use min max scaler. I will also give you example where min max scaler can actually be used. So you might know that we can use AI for predicting whether it's a cat or a dog. So let's say in a given image. So let's say we have these two images. Here is a dog and here is a cat. We want our machine learning model to predict between the dog and a cat, like classify a dog image and a cat image. So what we will do is we will scale this image between 0 to 255 pixels. So it will have maximum 255 pixels and minimum 0 pixel. And also while predicting, we will process the prediction data so that the again the image that we are giving as an input while predicting is again in the format of 0 to 255. So like 255 pixels. So it knows that the minimum pixel that it will have, pixel value that it will have is 0, and the maximum pixel value that it will have is 255. Yeah, and this remains same during its training process and also its prediction process. So the min max scaler, so it will assign so it will assign 1 to 255 value and 0 to the 0th pixel value. So what it will do is assign 0.25, 0.55 or something like that to all the values, to all the rest of the values, because it knows that that no pixel value can go above 255 and no pixel value can go below 0. So this is the proper case where min-max scaler can be useful. But in our case, as I explained before, we can't really use min-max scaler, so we are going with the standard scaler. Okay, so now let's come to the part where we will understand what does the scaler that we are using and is actually doing. So if you remember, I told you before that during data pre-processing, which is what we are doing now, we process the data such that its statistical features remain the same. This is what I have told you before. But the standard scaler that we are using is little complex. What it does is it changes the mean value of the data to 0 and the standard deviation value of the data to 1. However, it is very important to note that during this it analyzes each data point in the actual data. So like let's say that the first data point is related to the second by a factor of let's say 2. So if we multiply this by 2, we will get this data, and let's say the second data point is related to the third data point by a factor of 3. So if we multiply the value of this data by 3, we will get the third data. So it maintains this relation between the data points and it processes the data. It changes its mean mean of the data to 0 and the standard deviation to 1, but it does so such that the relation between these data points remains the same, and then it gives us the new data, which is the process data that can be fed to the model directly. Again, it might be useful to know that the thing I was talking about, that when we pre-process the data and perform some mathematical calculations on it, the statistical features remain the same. this is when we are the data pre-processing is like very basic, like it's like very basic and very simple. The data pre-processing that we are doing in this case is is known as standard scaling, and even during min-max scaling, some of the statistical features like mean mode might change. However, like min-max scaling, and however both the min-max scaling and the standard scaling process the data such that the relation between these two remain the same. The main difference between the min-max scaling and standard scaling is relation. I mean the relation between the data points remain the same. So the main difference, as I explained here. So the main difference between the min-max scaling and standard scaling is here the min-max scaler assumes that there is a higher value and the lower value, assigns it 1 0 and scales all the values between this. However, the standard scaler does not do this. It instead directly analyzes the data points, the relation between each data point, and performs some mathematical calculations on them such that this relation remains the same as it was in the original data point. So if we analyze the relation between the data points in this processed data, it will be exactly the same as it was in the original data. Okay, so now again let's go back to the Visual Studio Code window. Now here, as you can see, we have initialized the standard scalar. Then what we have done is just one statement, one line of code, and Python does it all for you. So we have wrote here that scalar dot fit transform. Scalar is standard scalar. So scalar dot fit transform the data set. So we have passed this array. So now it will use the standard scaling method. It will change the mean and mode, as I told you, mean and standard deviation, as I told you before. And then now we have a new data which indeed represents this the actual data, but all the values will be scaled so that they are numerically very low. So as I told you before, this is in the range of like 16,000, 17,000, and so. But now if you find out what's the data after this, it will if we print out this data, it will actually give you values in a very low range, like 1 to 10 or maybe 1 to 20 or even maybe 1 to 50 and so on. It might even transform the data so that the data values become negative. However, while doing so, it will, as I told you before, the relation between the data points remain the same. So now once we have our data pre-processed, and so now once we have our data pre-processed, here we are trying to get the closing prices, the close prices column. So here is the closing prices column, this is the closing prices column. So now from the entire data set, we will just extract the closing prices column. Okay, so to do this, first we have defined the variable close price dataset. It will contain only the closing prices column. Now we will take the main dataset which contains all the rows and all the columns. So dataset, and now what we have done here is known as slicing in Python. So this represents rows and this represents column. So here we have typed column, which means that we want all the rows and we want the third column. So this third column actually represents the closing data prices. So if you will find, if you see here is our first column, second column, third column, fourth column, fifth column. However, while indexing, it will start from open and assign it 0. So 0, 1, 2 and then 3. But why we have skipped this timestamp column? It is very simple. As I told you before, this is actually our index column. So while counting here, we will not take into account the index column, as it doesn't matter in the dataset and it is just to uniquely identify each column. So while counting, we will start from here. This is our index column. So index, then 0, then 1, then 2, then 2, then 3. So we want the third column, and then what we will do is we will reshape it. So if you know the concept of reshaping, we will reshape this array we will again, while reshaping, this is row and this is column. So -1 means we will tell the Python to automatically define the number of rows, and since we are only taking the closing prices column, we will tell Python to shape this so that we will tell Python that this data set will have only one column, and Python should automatically assign the number of rows to it. So this brings us to the end of the part 1 of our project. So I will end this video here, and in the next part of this video we will see what are arrays, what is actually this what does actually this reshaping means, and what are row columns, and what are the shapes of the arrays, and what is dimension of the array. So thanks for watching till here. I will see you again in the next part.